Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Welcome back in lecture 01 part 10. Student, this is one of the most important lecture in these 10 parts. In this lecture, basically, I will derive this equation as in front of you. This equation is used for the area of steel, right? This is used for the determination of area of steel. As you see, A is equals to 0.85 Fc prime divided by Fy into B, D minus D square minus Mu divided by 0.3825 C prime B. Okay, bracket close. This equation is very useful equation, right? Because most of the time when we are solving the examples by trial and error method in ACI code, basically we are using trial and error method, direct methods, and we have some charts, or you can say we have some design aids. Okay, so by using those design aids, we will design any member or any member, right? So this equation is basically a very wonderful equation, you can say that, because it decreases the calculation up to a certain limit. If you are using, you will see in the calculation we will use the trial and error method. And trial and error method, what we do basically, we assume some value of A, that is the depth of concrete block, by just assuming 0.2 times of D, and then we calculate area of steel, right, from the equation, right, Mu divided by 0.90 Fy into D minus A over 2, right? So from this we got area of steel. Then again we recalculate the A value, right, from this equation. From this A is value, that is A is Fy divided by 0.85 Fc prime into B. If this A value is close to this supposed value, so the area of steel is okay. If it is not close, or if it is not equal to that previous one calculated value of A, we will use the second trial. This was the first trial, this was the second trial. In second trial we again recalculate A is 2 by using this time this value of A here, the value which we are calculated from this one, right? So we just plug again this A value in this equation, we got a new value for A is 2, and then again recalculate A2 by using this A is 2 this time, and then we checking whether this A2 is closing to A1 or not, or whether A is 2 is closing to S1 or not. So here we have again used trial and errors. We will use 4 to 5 trials and we see whether the values are closing or not closing. Sometimes they may not close, so we have to repeat the process. So this is a little lengthy process by using this trial and error method. Today I am showing you the most easiest way, that how you can use easily this equation, right, and how you can find out the area of steel. So let us prove this equation, how we get this equation, because most of the time student asking for the derivation of this equation, because most of the teacher even they do not know the derivation of this equation. Okay, so let us start and derive this equation, right? First of all, using the basic moment equation, right, we know that Mn, right, P times area of steel Fy into D minus A over 2, right? We will derive this equation as in our part 1, 2, 3, okay? So please go and watch those lecture again. Now we know that area of steel, okay, we know area of steel, that is the steel ratio, area of steel ratio times B into D. And similarly we also know the value of A, that is A is Fy 0.85 Fc prime into B. So here we plugging this A is value and A value here. What we got here, MNR, when we are using this factor, this Mn becomes Mu. Okay, we can replace this by Mn with Mu, right? So here we have phi rho Bd Fy into D minus, we are just plugging the value of A, so A is Fy divided by 2 times 0.85 Fc prime into B, right? Bracket close. Now we are using here some factors, right? The first factor is, let's say, M. M is a factor which is equals to Fy divided by 0.85 Fc prime, right? This factor will be used. And similarly, we also know the resistance factor, that is R, and we know that is Mu divided by pi Bd square. We have derived this value, I think so, in part 3 or part 4. So let's see, Mu divided by, we just shifting these P value and this B value, sorry, not B value, yes, B value and Fy value, right? So phi B and Fy, right? And here we have what we have on the right side, rho D, and from this, right, from this side, let me write down here, D S will be equals to rho Bd Fy divided by 2 times 0.85 Fc prime into B, right? Now just taking this D common, right? So this D will becomes D square. Here D will be cancelled. We have only one right here, and here we have rho. This B will be cancelled out. Okay, this B will be cancelled out with this B, right? And this D will be cancelled out with the, because we are taking D common, so that's why rho Fy divided by 2 and 0.85 Fc prime, right? So finally we have this one, right? Here we have on the left side Mu phi B into Fy, right? So what we have further, let me, on the left hand side, Mu divided by phi B, and shifting this D square to the left, we have D square Fy equals to rho into 1 minus, now here we have this one, okay, this factor Fy 0.85 Fc prime, by just we already write down here that M equals to Fy 0.85 Fc prime here. So plugging the value of M divided by 2, right? Okay, so finally we have this equation, right? And we will multiply this row, right? So this side, okay, so we will replace this Mu divided by phi Bd square with R. So we have R, let me change the color, R divided by Fy equals to, multiply this row with 1 minus rho square M divided by 2. multiplying 2 on both side, okay, 2 on both side. So here we have 2r divided by fy equals to 2r minus rho square into f. So what we basically got a quadratic equation. Let me write down in sequence this equation. This rho square m will be shifted to the left side. So we have rho square m, this one with a negative sign, 2 rho and plus 2r divided by fy equals to 0. This is a quadratic equation, right? Now we have to solve this quadratic equation. So let us solve this quadratic equation, right? Here we have a equals to what? A equals to m, because we are using the quadratic equation, quadratic formula. B we have minus 2 and C we have 2r divided by f. Why? We know the quadratic formula. We just plugging these values in the quadratic formula. We got rho equals to minus b. Minus b, so we have minus 2. So we got 2 plus minus under the root. Okay. So here we have b square. So we got 4 minus 4ac. A, m and c is 2r divided by fy, right? And divide this by 2a. So 2a, 2m, right? Now we will just choose the we have to take the positive root as well as we have to take the negative root, right? So just let's say we are taking the negative value, right? Because we have minus minus, right? So let's say 2 minus, okay, and here we have 4 and 4, so taking 4 common, right? Taking 4 common, we have 1 minus 2mr divided by fy, right? And here we have 2m, right? So 2 minus this 4 will be shifted to the outside of the root, so it will become, because we know that 2 square under the root will be equals to 2, because 2 times 2 equals to 4, so that by 2 into, right, 1 minus 2mr divided by fy divided by 2m, right? So finally what we have next, rho equals to, taking 2 common, 1 minus under the root 1 minus 2mr divided by fy divided by 2m, 2 cancel with 2, so rho equals to 1 over m, 1 minus under the root 1 minus 2mr divided by fy, right? So this is the equation which is used for the determination of area of steel. One of the most important equation this will be, okay? You have to mark this as equation 2, because we will use this equation as in our calculation, right? So you must remember this equation. Now next we are jumping to the derivation of the main part of the equation. So here what we have next, let me write down here. We know that area of steel is what? This is area of steel ratio times B into d. We know the row value which is we derived right here. So here we have area of steel equals to, we are just plugging the value of row, this value right here. So what we have, 1 over m into 1 minus under root divided by 1 minus 2mr divided by fy into bd, right? Now we are plugging again the value of m and the value of r. So what we have next, okay, what we have next, right? A is equals to 1 divided by, we know the value of m, that is fy divided by 0.85 fc prime, right? 1 minus under root, right? 1 minus 2, we will plug the value of m, that is fy divided by 0.85 fc prime, okay, and we will have the r value, and the r value is what? mu phi bd square, right? And again we have this fy, which is 1 over fy and bracket close, right? So from this we will cancel out some values, right? So let me change the color. We will cancel this fy with this fy, right? We will shift this 2 to the denominator, and so let us here what we have, we will shift this value to the denominator. So here we have 0.85 fc prime divided by fy, and we will multiply this b, because we have here we have bd, right? So we will multiply this b to the left, right? So here we have b, right? And similarly we multiply this d to the inside of the brackets, so d minus d, right? And here we have under root 1 minus mu divided by 0.85 times p value divided by 2, because we are shifting the 2 right here to the denominator, so it becomes in division right here, and p value will be this one. We have 0.85, okay, so all the values are right. So here we have fc prime into b, right? So next we have this d square value, so d square right here, okay. So now we have to multiply this d, or we have to bring this d inside this square root. So let me bring this value 0.85 fc prime divided by fy into b. Now here is d minus. So how we will bring this d inside this under root? We will square it and we take the square root. So by doing this, we will bring this d inside this square root. So that why it becomes d square minus mu. So here we have d square. That d square will be cancelled out with this d square. So finally we have, and we will multiply 0.85 with phi value, that is 0.9, and divide this by 2. What we got? 0.3825 FC prime into B, right? Finally we will got, because this D will be here it will be D square. Similarly here we will have D square, right? So let's say this is D square, and similarly in denominator we have D square right here, so that D will be cancelled out with that D square. So that why I'm not writing that value. Okay, so let me rub this value. Okay, so finally we will derive our equation, and okay, so let me write down here what we finally got, right? We will derive the equation for area of steel. Okay, for area of steel, that is A is equals to 0.85 FC prime divided by Fy into B bracket D minus square root D square minus mu divided by 0.3825 FC prime into B bracket close. Remember, you have to be consistent with units. If here you are let's say you are using KSI, right? So here KSI cancel out with KSI, so here it doesn't matter. But B, D and MU, okay, you must make sure that you are plugging the right value. I always recommend that bring all the values in inches and KSI. So if you are using FC prime, let's say 4000 PSI, so plug here 4 divided by 60, and value of B will be in inches, D value will be inches, and bring the MU value in kif inches, right? Inches kif. So by doing this, you will be consistent with units and plug all these values in one time in calculator. You just simply derive the value of A is, okay, which is the most easiest way and the most quickest way that you can got the value of A is. So this ends up this derivation, that how we will derive this equation. You see the steps right here, that how we will derive this equation, and this is the one of the most important equation. Remember that it will be used in the examples. See you in next lecture. Thank you for watching.